This will be video 3 for section 5.1, and it'll be problems 5 and 8, so it'll go pretty quick. Both of these are calculator questions. The only difference is, notice it doesn't say use a certain number of intervals. It just says what is the area. So what we're going to do is we're going to just do a little experiment by running RAM, and we're going to, increase the number of intervals, do a little inductive reasoning to see what we see. So first we plug in x squared minus x plus 3 into y1 into y equals for graphing, except we're not going to graph it. Then we're going to go to program. We're going to run RAM, and a is 0, b is 3, and number of intervals. That 500 took a long time, so let's just see what 20 gives us, because that'll go quick. Okay, so with 20 intervals, I got left is 13.06125. I got 13.494375 and 13.96125 for left, middle, and right. Alright, so 13 something seems obvious, but let's do this again. 0 to 3, and I don't know, let's do 50. And with 50, I get 13.3218.4991 and 0.6818. Okay, not convinced yet, so we're going to go again. We'll go from 0 to 3, and let's just sort of cut to the chase, and let's do like 250. And we're waiting. And we're waiting again. Good television right now. I suppose while we're waiting I could draw you a pretty picture of something. But I'm not a very good artist. There we go. Alright. I've got now 0.464072, 0.499964, and 0.536072. Alright. So, I'm going to take a look at the graph of this function. Zoom 6. Okay, so you'll notice if you graph this function that it looks about like this. So, anytime your function is increasing the whole time, it looks like it pretty much is. When you do left rectangles, then we're making our rectangles from the left side, and you'll notice that that will always be an under approximation. And the converse of that is if you do it from the right, you're always going to be an over approximation. And the midpoint isn't going to be exactly right or anything. It all depends on the symmetry of the graph. But in general, I think it would appear that the midpoint is probably closest. But it would make sense that this is lower than it should be, this is bigger than it should be, and this is closer to accurate. So I think I'm ready to call this thing and say that the area is going to be 0.5 units squared. Okay, so now let's quickly do the next one, which is simply, let's check my mode, yep, radians. Sine of x. Alright. And thinking about what sine of x looks like between 0 and pi, it looks like this. So left and right, because of the symmetry here, should be exactly the same number. And so this one we should narrow down pretty quick. Okay, so let's go run the program. 0 to pi. Let's use the pi symbol. And let's just jump up there. Let's do 100. Might as well not waste our time. So left, middle, and right. All right. And we're waiting. And we're done. And I think we're going to just call this one already because it looks pretty convincing. We got a bunch of 9s, 8, 3, 5, 5. I'm not going to write it all down. So we're almost 2. This one is a little over 2, and this one is the same as left. And so again, I think we see where this is heading. Looks like the area is going to be 2 square units. Okay, so we're going to end this video here, and we'll pick it up with some table questions on number 10.